Good afternoon and welcome to the Q&A session 18 from the chapter of Properties of Matter. The topic is the laws of flotation, and today I have taken one question which is based on this topic. So the question here is: a hollow sphere of volume V is floating on the water surface with half immersed in it. So the minimum volume of water required to be poured inside the sphere so that it is completely immersed is. So here we have been given four options and we have to find the correct option. So here we have got one hollow sphere of volume V and it is floating on the water surface with half immersed in it. So in this condition, that is when it is half immersed, then in this condition, when the sphere is half immersed, then in this condition, the weight of the sphere should be equal to the buoyant force, and the weight of the sphere will be acting vertically downward and the buoyant force will be acting vertically upward, and in the state of equilibrium, when the sphere is half immersed, the weight of the sphere should be equal to the buoyant force. So the weight of the sphere, let us say the mass of the sphere here is small m, so m into g will be the weight of the sphere, and the buoyant force will be equal to the weight of the liquid displaced. Now since the sphere is half immersed, so the volume of the liquid which will be displaced will be equal to V by 2. So the weight of the liquid displaced will be equal to the volume of the liquid displaced multiplied by the density of the liquid. Now let us say here the density of the liquid of water is rho. I am taking the density of water as rho. So this is the volume of the liquid which will be displaced because the sphere is half immersed, and the density of the liquid or the water is taken as rho multiplied by g. So from here I am getting one relation, that is from here g and g will get cancelled out. So I am getting one relation, that is m is equal to v into rho divided by 2. Now when the sphere is completely immersed, after some water is poured inside the sphere, then in that case the buoyant force will be equal to the weight of the liquid displaced. So in this case, since the sphere is completely immersed, so the volume of the liquid which is displaced will be equal to V. The density of the liquid or the water is taken as rho into G. So this is the buoyant force which will be acting on the sphere when it is completely immersed, after some water is poured into the sphere. Now let us consider that the volume of the water which is poured into the sphere is equal to, say, V dash. So the weight of the sphere plus the weight due to the poured water this will be equal to, the weight of the sphere is equal to m into g plus the weight due to the poured water. So now that will be equal to the mass of the water multiplied by the density of the water. So that will be, sorry, the volume of the water multiplied by the density of the water. So that will be equal to the mass of the water multiplied by g. So this will be equal to, now here we have taken the volume of the water which is poured into the sphere so that it is completely immersed. This is equal to V dash. So V dash into rho, rho is the density of the water, into g. So this is the total weight which is acting vertically downward. So in the state of equilibrium, this buoyant force should be equal to the total weight which is acting vertically downward. Now here the buoyant force is equal to V into rho into g. So in the condition of stable equilibrium, V into rho into g, this should be equal to m into g plus V dash into rho into g. So this is another equation which I have got. Now here mg, plus, this is plus. In the case of stable equilibrium, this buoyant force, that is V into rho into g, will be equal to the total weight which is acting vertically downward, which is equal to mg plus V dash into rho into g. So from here I can simply this g will be cancelled out, and here the value of m is equal to V into rho upon 2. So V into rho is equal to, m is equal to V into rho upon 2 plus V dash into rho. So from here this rho will get cancelled out, and finally V dash is equal to V minus V upon 2, and simply this is equal to V by 2. So the minimum volume of water which is required to be poured inside the sphere so that the sphere is completely immersed will be equal to V by 2, and the correct option is A, that is V by 2. So thank you very much for joining this session. In the next session I will be coming up with a different type of a question from the topic of either this laws of flotation, or it can be from the topic of buoyant forces, or it can be from the topic of this Archimedes principle. So till then, have a nice day. Bye.